Let's solve a couple of problems on falling things. Here's the first one. Deadpool drops from a height of 45 meters. Find the time it takes for him to reach the ground. G is 10 meters per second squared. So let's look at what's given to us. We have Deadpool who's dropping from a height of 45 meters. So let's draw a diagram. Here's our Deadpool, a superhero who always puts his maximum efforts in catching bad guys. He's dropping from a height of 45 meters. That means the height right now is, this height is 45 meters. We need to find the time it takes for him to reach the ground. So how do we solve this? Well, remember that whenever things are falling under gravity, they have a constant acceleration of 9.8 meters per second squared. In this problem, they've asked us to round it off to 10. So this is the acceleration with which Deadpool is going to fall down. Okay, so what? Well, whenever something has a constant acceleration, then we can use three equations of motion to solve them, where v is the final velocity, u is the initial velocity, acceleration, time, and s is displacement. Now, if you're not familiar with these equations or you need a refresher, great idea to go back and watch videos on equations of motion and then come back over here. And so we'll write down what's given to us and what is asked, and we will see which equation to use to solve the problem. Okay, it's given that Deadpool drops from a height of 45 meters, which means he's going to fall down, he's going to displace by 45 meters. So we know the displacement is 45 meters. We also know his acceleration. His acceleration is going to be 10 meters per second squared. Now what's important is accelerations can be both positive and negative. Whenever objects speed up, we say their acceleration is positive. And whenever objects slow down, we say their acceleration is negative. So in this example, notice Deadpool is going to speed up. As he falls, he's going to go faster and faster, right? And so in our example, we'll take acceleration to be positive. What else is given? It seems like it's only these two things are given, right? But there's one more information, which is pretty important. It's given that Deadpool drops from the height of 45 meters. Whenever something is dropped, we know its initial velocity is 0. Okay, so we know the initial velocity of Deadpool, that is 0. And we are asked to calculate the time it takes for him to reach the ground. That means we need to find what t is. So now we just have to select which of the equation we can use to solve the problem. And before I do that over here, great idea to pause the video and see if you can select which equation you would use to solve this problem. All right, let's go through each equation one by one. Can we use the first one? No, because the first one has v in it, which we don't know. Can we use the second one? We know s, we know u, we know a. Hey, we can use the second equation. We can go for this equation. What about the third one? The third one doesn't even have t in it, so even third one we can't use. So we have a winner. We're going to use equation number 2 and substitute and solve the problem. And again, if you didn't solve it earlier, now would be a great time to again pause and see if you can go ahead and plug in. Okay, let's go ahead and substitute. S is 45 meters. That equals u, which is 0. And so this whole term goes to 0, which I will not write, plus half times a, which is 10 meters per second squared, times t squared. And now all we have to do is solve this equation and we'll be done. So let's simplify this. Let's see what we get. 2 goes 5 times. And a meter cancels over here. And the 5 goes 9 times over here. So what do we have? We have 9 on the left-hand side. And we have t squared on the right-hand side divided by second squared. So if I multiply by second square on both sides, I will now get 9, let me write that over here. I'll get 9 second squared equals t squared. And now since I want to calculate what t is, let's take the square root on both sides. Square root of 9 is 3, square root of second square is seconds, equals t. And there's our answer. So t is 3 seconds. That means Deadpool takes 3 seconds to land on the ground. Now, before we proceed, one question we might have is square root of 9 is both plus 3 and minus 3, right? So why did we ignore the minus 3? Well, because if time is minus 3, it is less than 0, and that represents the past, because time is 0 is the present, it's right now. So less than 0 represents past, more than 0 represents future. Since we are asked to calculate how long it takes for him to reach the ground after he has dropped, we care about the future. And it's for that reason we only consider the positive time. And so you'll see in most of the physics problems, whenever we're asked to calculate the time, since we are asked about the future, we'll only consider the positive ones and we'll ignore the negative ones. So negative values. So anyways, let's now consider another problem. Spider-Man jumps straight up with a speed of 20 meters per second. Calculate the maximum height he reaches. Again, given g is 10 meters per second square. Can you try to solve this one yourself? Again, make a quick drawing of this, see what is given, what is asked, and then pick an equation to use. All right, let's see. So we are given that the Spider-Man is jumping straight up. So let's draw that. So here's our Spider-Man who's jumping straight up with a speed of 20 meters per second. We need to calculate the maximum height he reaches. So eventually he'll reach a maximum height and then start falling back, right? So we need to calculate what that maximum height is. What is that distance? So again, let's write down what's given to us. We know the initial velocity with which Spider-Man jumps. So we know u, that is 20 meters per second. We also know the acceleration. Whenever things are falling under gravity, immediately we know its acceleration. Acceleration is going to be, now this time, is it going to be plus 10 or minus 10? Well, this time, as Spider-Man goes up, he slows down, right? He slows down. As a result, he's losing velocity. And since he's losing velocity, the acceleration becomes negative. It's a deceleration, right? So the acceleration becomes minus 10 meters per second squared. Again, that's the important part over here. What else is given? Again, it feels like these are the only two things given, right? But something else is also given. Again, this is super important to figure out. We are asked to calculate the maximum height. And at the maximum height, we know the velocity of Spider-Man. At this point, if this is the maximum height, his velocity must be 0. That means we know his final velocity is 0. How do we know that? Why is it so? Well, think about it. If Spider-Man did not have 0 velocity, if say he was still going up with some velocity, then this wouldn't be the maximum height. He is yet to reach the maximum height, isn't it? On the other hand, if Spider-Man was going down with some velocity, that means he has already reached some maximum height and now he's coming downwards. So the only possible velocity for Spider-Man at the maximum height must be 0, right? Think about this. All right. And what we are asked? Well, we are asked to calculate that maximum height. So in this case, we are asked to calculate the displacement. That's what we need to know, the displacement of Spider-Man. Again, which equation do we go for? Now, again, if you want to try this on your own, great idea to pause and see which equation you would go for. But let's see. We can't use the first equation because it does not have s, it is useless. What about the second equation? Hey, we can't use that because there's a t in it and we don't know the time. So that only leaves us with the third equation. And so we can use equation number 3. And if we substitute these values, which I'm pretty sure you can do now, we will get 0 equals 20 meters per second squared plus 2 times minus 10 meters per second squared times s. And to save time, I'm pretty sure you can do this yourself. I'll tell you what the final answer turns out to be. If you calculate that, if you simplify, you will get the displacement s to be 20 meters. That means Spider-Man reaches a maximum height of 20 meters. And so whenever things are falling under gravity, because they have a constant acceleration, we can always use the 3 equations of motion and solve our problems. Now, there are a couple of things to be careful about though. One is the sign of the acceleration. When objects are thrown up, because their velocity will decrease, where our acceleration will be negative. If the objects are thrown down, the acceleration becomes positive. Another thing is sometimes the data is not given directly, it's a little hidden. For example, we were given it reaches maximum height, but we had to understand that maximum height means the final velocity is 0. Similarly, in the previous problem, it was given that he drops from a height. We had to understand that drops means that initial velocity is 0.